Assalamualaikum everyone. My name is Hamza Abdul Bait. I would like to explain you about the maximization problem using Hungarian method. These are the three steps to solving our problem. The first step is convert to the minimized problem by multiplying an element from cos matrix with -1. And step 2 is if some of the elements from the cos matrix are negative, then add a huge positive number for each row and column so the element become positive. And the third step is apply the Hungarian method. Okay, this is the example for our problem, the maximization problem. The first step, we need to make this element of the cos matrix into the minimize matrix, minimize element by multiplying all of the element with -1. So the matrix will become like this. Okay, and -2 plus 6 is equal to 4, and so on until the fourth matrix. Okay, the third method is we apply the Hungarian method. In this step, we put some line that must cover all of zero element from this cos matrix. And we end this step if the amount of line is equal to the amount of column. Okay, so like this. This is there are three lines, so this matrix is not a feasible solution. Okay, the next step after we cover the zero element of this matrix is determining the smallest number on the untouched number of this matrix. Okay, for this case, the smallest number from the untouched matrix by line is 3. Okay, after determine the smallest number, we do some addition and reduction. We reduce the untouched number with the smallest number, so the untouched number will be reduced by 3, like this. M plus 6 minus 3, 4 minus 3, 3 minus 3, 4 minus 3, 5 minus 3, and 4 minus 3. And then there are two number that touch by two line, like this, 4 and 1. So we need to plus this to add this number by the 3. 1 plus 3 and 4 plus 3. So the matrix will become like this. 4 plus 3 it is equal to 7. 1 plus 3 is equal to 4. 4 minus 3 is equal to 1. 4 minus 3 is equal to 1, and so on. Okay, we do the matrix modification, the second matrix modification, because this is not feasible solution yet. So we need to modify this matrix with the pass method, aligning cover the zero number with the line, because the amount of line is still not equal to the amount of the column. So we cover all of the zero with the line. Okay, like this. And we do some step like before. We determine the smallest number from the untouched number on this matrix is 1. So there will be like this: 2 minus 1, m to 3 minus 1, 1 minus 1, 3 minus 1, 2 minus 1, and 1 minus 1. And the number that touched by the 2 line, it will become, yes, add by the smallest number from the untouched number by line. So we add 1 with 1 and 7. So the matrix will become like this. Okay. After this, we can try to determining the plotting the job, the machine, with the job. Okay, we can determine the machine with the job from the zero element. Okay, like this: machine 1 will done job 1 because there is a zero number that meet at the first row and first column, and the machine 2 will do job 2, and machine 3 will do job 3, and machine 4 will do job 4. Okay, we have to back to the first matrix. We turn it back to the first element, first number, like this: 0 becomes 6, and 0 in the second row become 5, and so on. So we can determine the z by add all of these element. Okay, at this case, machine 1 do job 1, machine 2 do job 2, and machine 3 will do job 3, machine 4 will do job 4. So the z will become 22. Okay, but we can see this is not only a feasible optimum solution, because there is a lot of zero number. There is a possibility the another feasible optimum solution. Okay, we can try. Okay, like this: the machine 4 doing job 1, machine 3 doing job 3, machine 2 do job 2, and machine 1 do job 4. There is only change with the machine 4 and the machine 1, but the result is still same, 22. This mean the answer is correct because all machine have done given the job. Okay, this is the alternative optimum solution. This is alternative. Okay, that's all from me. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.